Welcome to the PrairieLearn Pico Emulator overview video. This video is made by the Senior Design Team, May 2024, Group 33. So in this video, we're going to go over a couple things about our Pico emulator. First is the repository structure, then the script walkthrough, creating custom C code, and using the script. In general, this emulator is one of the two emulators designed by the team. This one currently has UART functionality and was used as a secondary emulator that can be used for things like auto-gridding, generating code, etc. We'll go more into that within this video and the other videos on the emulator. First, the repository structure. This is just a general overview of the structure of the emulator files and mostly what are the most used files. More detailed file information can be found in the configuration overview video as well as the written documentation. As you can see, we have the emulator folder inside of the repository for the team. Within here, there is a build hex files directory that has a build directory within it with the build hex files.hex file. This file is used to store the generated C code from build hex files.c, as you see below. And then this file is then placed into the rp2040js directory seen at the bottom, where it is then run on the emulator. In conjunction with this, we have the emulator.sh, which is the script that runs the emulator itself automatically, so none of this has to be done manually. It was the npm output txt file, which displays the output from the emulator running code. The Pico SDK is also a directory where all the SDK information is stored for the emulator. So, first what we're going to do is start with a script walkthrough. We're going to go through what it does, how to use it, and how to modify it. So, inside of our Linux VM environment, we're going to navigate to our terminal, and we are going to cd into our SDMA33 directory. If you have not already cloned this repository, please do so. Inside of here, we can also change into the emulator directory. From here, we can see all the directories shown in the file structure video, and especially the emulator.sh script. To use this script, all we have to do is run /emulator.sh from within the emulator directory. This will take a moment to execute, however it does have a timeout set on it so that it does not take too long to execute. This can be configured, as you will see later. Right now there is an npm warning. This is something that you can modify. As my system is not currently updated, it will have this. Now if we view the npm output, you can see hello world is printed. If we open up the emulator.sh file itself, we can see that this is a bash script that is going to configure the emulator, update the C file, and run the emulator. I will not go into detail on what every single command does, but as a brief overview, some things that are done are configuring the Pico SDK path, making sure that the proper utilities are all installed, which will all ask the user for their password if needed for sudo privileges, to configure the file path, execute the build the code, hide the external output so that the script is quiet, change into the proper directories, copy the proper files, and run the code using npm. Down here you can see that timeout I talked about. Right now it is set to 5, but for your usage of the emulator you may modify this to whatever it is. This also outputs to the text file that we saw earlier. As previously stated, modifying this script is fairly easy. Things like the outputs to keep the script silent, the paths created need to be updated for any modification of the file directory structure, and things like the output of the file are also things that are very useful to edit if need be. The current configuration of the repository means that this is not necessary if you wish to keep the current configurations. So now that we've seen how the script works, we want to talk about what actually the script does. So creating custom C code is something that the user or our backend is able to do and use the script to execute it. This can run any standard C code as well as any microcontroller specific C code, which is the main point with the emulator. This is something to note that the Pico that this emulator was originally based off of by Wopley is different to the TM microcontroller used by the CPRE 288 course at Iowa State University. In the next steps video, as well as the custom configuration video, you will see what the differences are and what needs to be still done to make this emulator fully functional. As of now, there are certain functionalities that we will demonstrate to show you what is currently working and what you should be using if you want to experiment with the emulator. Once we have the custom C code changed, as you saw me do in the demo earlier, we use /emulator.sh from the emulator directory to run it, and the output is seen in npm output.txt. Now we will show some of the editing custom C code so you really know what is happening. Within the VM, we recommend using Visual Studio Code to utilize the editing of C code as it is also used within the script. From here, we go to File, Open Folder. We navigate to our SDMA folder, go into our emulator, and the build hex files directory. As we said earlier, the build hex files.c file is where the C code lives that is executed. Opening up this file, we can see the current configuration is listed to be hello world. This uses UART0 and the data register to write to the terminal. However, we do see that we pipe our output and redirect it to the npm output.txt file. For example, if I were to erase this and just leave the H, we can go return to our terminal, run our emulator script, wait for the output to finish. While we do that, we can open up the file that the output is directed to. Remember, we go to the npm output.txt file, and as you can see, just H was printed instead of the main hello world that was existing earlier. This is the simplest way to write to the terminal, and this is currently the functionality of the microcontroller emulator in its current stage. So to wrap up this short video, what we've seen is that how to configure the script partially, as well as how to use it to execute custom C code in the simplest way possible. If you want more information, the written documentation linked within the description of this video, as well as on the official website and Git repository, is the best way to learn more. The configuration and next steps videos will also go into this detail. We highly recommend watching these videos or reading the documentation before getting started with the emulator.